Hi everyone. Let's see how to write all the formulas. So, general formula and molecular formula we have discussed in the previous video. So, over here, let's say, suppose alkane, okay? If it is alkane, the general formula will be CnH2n plus 2. So, any alkane you can take. Let's take ethane or propane. Yeah. So, propane, we know 3 carbon atoms, right? 3 carbon atoms. So, C3, what is the formula? C3 H2n plus 2, which means 2 into 3 plus 2, which is 8. So, C3H8, which is the molecular formula. How to write the structural formula? Structure in the sense structural formula, or you can say condensed formula. So there are 3 carbon atoms, right? So it's 3 carbon atoms. So each carbon atom, the first carbon atom has 3 hydrogen, second carbon atom has 2 hydrogen, and third carbon atom has 3 hydrogen. So this is structural formula. So you can ask me how we can say that second carbon atom has 2 hydrogen atoms. So if you see the displayed formula, you will understand it. So there are 3 carbon atoms and carbon's valency 4, we know, which means this first carbon atom, if you take this carbon atom bonded with another carbon atom, and also it is bonded with 3 hydrogen. So valency satisfied. All the 4 electrons shared over here, right? So if you take this carbon atom, the last one, again 1 electron shared with this carbon atom, and the other 3 electrons are shared with 3 hydrogen atoms. So if you take center carbon atom, which is already bonded with 2 carbon atoms both the sides, which means it can share only 2 other electrons. So those 2 electrons shared with hydrogen. So that is the reason it is CH3, CH2, CH3. One thing you can keep in mind, how much lengthier it is, like pentane, 5 carbon atom in the sense. The first and last carbon atom always will be CH3, and in between 3 carbon atoms you can write CH2, CH2, CH2. Okay, that you can, how much ever lengthy it is, you can, if there is no branch over there. So then how to draw skeletal formula? Skeletal in the sense, easily you can find by seeing this line. So what, how we can say it is propane. So over here, we should consider 3 carbon atoms, 1, 2, 3. So there are 3 carbon atoms in this, so it is propane. Suppose for pentane, how can we show one more line? Sorry, butane. Pentane will be this. Hexane will be this. Heptane, octane, nonane, like that it goes. Okay. So over here, this is for propane. You no need to keep any dots here, but just to understand like that here. Okay, what is the empirical formula? Empirical formula means the simplest formula, which means simplest ratio. What is the ratio here? 3 carbon atom, 8 hydrogen atoms. Is it possible to simplify it? No, we cannot simplify it. So that is the ratio. 3:8 is the ratio, which means the formula, empirical formula is again same molecular formula. Okay, suppose let's take butane. So if it is butane, again, what is molecular general formula will be same, CnH2n plus 2. Molecular formula will be C4H10. So in this case, same way, 4 carbon atoms, So 4 carbon atoms in the sense each carbon atom has, the first and last carbon atom has 3 hydrogen. So over here, the rest of the 2 carbon atoms as CH2, right? So CH3, CH2, CH2. So which means when you display it, how will you display? When you display it, same way you will display it, right? So how we have showed over here, same way, similar way, you will display the butane, right? 4 carbon atoms. So which means over here, the first and last carbon atom has 3 hydrogen bonded with 3 hydrogen, right? And over here, these two has bonded with 2 hydrogens, right? Yeah. Valency satisfied. So how will you draw skeletal formula for this? As I told you, 1, 2, 3, 4, 4 carbon atoms. This is the skeletal formula for butane. And the empirical formula is, so here C4H10, we can easily simplify it. So it is, the simplified formula is what? C2H5. Okay, this is for butane. Okay, how to draw this alkenes? How to show alkenes? Suppose over here, let's see, let's take propene. Okay, so propene, what is the general formula for propene? Propene general formula C3H6, right? So C3H6. So how to show the structural formula here? CH2 double bond, CH single bond CH3. Or you can also show CH3 single bond CH double bond CH2. You can also show like this. Why? Because the position of the double bond matters. So over here for propene, both the ways, like wherever the double bond is, it's called propene only. Suppose if the position, like in butene, if it's with the first carbon atom, we say but1-ene. If it's with the second carbon atom, we say but2-ene. So in that case, the name will change. Name of the compound will change. So because of the position of the double bond. So over here, what is the, how will you draw the displayed formula for this? Same way, 3 carbon atoms and there's a double bond over here. So double bond, if there is a double bond, why we are putting double bond? Because you are removing hydrogen. You can easily compare with the propane structure. You are removing one hydrogen from both the carbon atoms, right? So that is why it is double bond over here. So with this carbon atom, we are not removing any hydrogen, so it is just CH3, right? So how will you draw skeletal formula for this? Same way, 3 carbon atoms, but there is a double bond over here. That's all. Okay, so this is propene. Now, what is the empirical formula? So you can easily understand one thing for all alkenes, because the formula itself shows CnH2n, which means for all the alkenes, the formula, empirical formula will be CH2. For all alkenes, it will not change. For all the alkenes, it is CH2. Okay, so this is how we have to write alkene. And suppose if it is butene, that's what, yeah. For butene, I'll show you the structural formula. Try to understand. CH2 double bond CH, single bond CH2 CH3. We are not touching the other 2 carbon atoms. Let's think of butane. What is the structure? And butene, you are removing 2 hydrogen from the first 2 carbon atom. So there is a double bond over there. So we call, sorry. So we call this as but-1-ene and CH3 bond CH double bond CH CH3. This is but-2-ene, right? So why but-2-ene? Because the double bond is with the second carbon atom. That is why but-2-ene. If the double bond is with the first carbon atom, it is but-1-ene. And the empirical formula will be CH2 only. But where there is a change again with what is it, skeletal formula, when you draw skeletal 4 carbon atoms, so which means if it is but-1-ene, the double bond will be over here. If it is but-2-ene, double bond will be over here, right? So that's the difference between but-1-ene and but-2-ene. Okay. What about if it is alkyne? What is it? Alkyne means the general formula will be CnH2n minus 2, which means let's say propine itself. Propine. What is the molecular formula? C3H4. How to show structural formula here? CH triple bond C single bond CH3. So why there is a triple bond over here? Why there is a triple bond here? Because both the carbon atom losing 2 hydrogen atoms each. So there is a triple bond over here. Okay. So we say alkene and alkynes are unsaturated hydrocarbons. Alkanes are saturated hydrocarbons because of this reason. Okay. So how will you draw a skeletal formula for this structure? If it's propane, there are 3 bonds. You have to show 3 bonds. Okay. So this is propane. So what is the empirical formula? Over here again C3H4. You cannot simplify more than this. So empirical formula also what? C3H4. Okay. And again same way, whatever, if it's pentine, 2 pentine, 1 pentine, with hexane, 3 hexane also will come, because the reason position of the triple bond. If the position of the triple bond is with the third carbon atom, it is 3. So it's hex 3. So this is how we have to find the structure. So all these structures are very important. So try for till decade and clarify your doubts. So in the next video, we'll see isomers. Bye.